Welcome to this explainer. Today, we're diving into AI-powered event response for Amazon EKS. Now, if you're a DevOps engineer or a site reliability engineer, you know the drill. Managing a modern cloud environment with dozens or even hundreds of microservices, it's basically like being a seasoned detective in a massive, sprawling city that literally never sleeps. You're constantly on the clock, searching for clues, trying to solve these wildly complex operational mysteries before the whole system just grinds to a complete halt.
But here's the problem. The sheer volume of clues is just completely overwhelming. You're trying to balance rapid deployments, which, hey, is fantastic for innovation, but suddenly you're bombarded with thousands of daily signals. Alerts are firing from every single microservice. You've got isolated infrastructure issues popping up, CPU spikes on one node, network latency dropping packets on another, error logs streaming in so incredibly fast that literally no human could ever possibly read them. The noise is absolutely deafening, and your on-call pager is essentially melting.
So, let's just take a collective breath. How do you find the root cause when your entire dashboard is just blinking red? It's the ultimate needle in a haystack problem, right? You're staring at an active production outage, the clock is relentlessly ticking, actual revenue might be on the line, and frankly, just looking at isolated, disconnected infrastructure clues, it just isn't cutting it anymore.
We've got a clear roadmap to solve this today, and we're skipping the abstract marketing fluff. First, the microservice monitoring challenge. Second, introducing AWS DevOps Agent. Third, learning the normal baseline. Fourth, investigating a production event. And finally, mitigation and future prevention.
Section 1, the microservice monitoring challenge, or dealing with the noise of modern environments. Okay, let's dive into this. Balancing lightning-fast deployments with operational stability remains one of the absolute hardest tightrope walks in tech today.
Which brings us to Section 2. Introducing AWS DevOps Agent, your autonomous detective. Think of this as the ultimate mentor for your incident response, a tool that already holds the blueprints to your entire Kubernetes architecture. So, the crucial point here is understanding exactly what this detective can actually do. AWS DevOps Agent is a fully managed autonomous AI agent built right on Amazon Bedrock. It brings true Kubernetes native intelligence directly into your incident response. Instead of just looking at isolated infrastructure hiccups, it actually comprehends your complex architectural relationships. It understands exactly how your pods relate to your deployments, which services are routing the traffic, what ConfigMaps provide the specific configuration, and how all the pieces natively interact. It's using natural language processing to read logs and machine learning to automatically identify issues. It's a real game changer.
When an investigation actually kicks off, the agent executes a very specific four-step discovery workflow. Step 1 is the initial scan. It queries the Kubernetes API for all resources in your relevant namespaces. Step 2, dependency analysis, where it builds a complete map of how all those resources relate to each other. Step 3 is telemetry correlation. This is where it takes your OpenTelemetry data and matches those discovered resources with their corresponding performance metrics, distributed traces from AWS X-Ray, and your logs. Finally, Step 4 is context building, aggregating the resource state and recent events into one single unified view. This means you aren't frantically jumping between 5 different dashboards trying to piece together what's happening.
Moving on to Section 3, learning the normal baseline, or establishing the status quo. Now, before our AI detective can solve a crime, it really needs to know what peace looks like. Think of this as the training montage phase. This is where we establish what a healthy cluster actually acts like on, say, a totally normal Tuesday.
During a baseline test, let's say we're generating a steady 10 requests per second, the agent observes and records 4 critical things. First, typical request patterns in latency, so it learns what a healthy response time actually is across all your services. Second, normal error rates. By understanding the expected noise floor, it learns to distinguish a genuine critical incident from just a routine low-level operational blip. Third, it tracks resource utilization, getting a feel for standard CPU, memory, and network usage across individual pods and nodes. And finally, service dependency relationships, identifying the normal upstream and downstream communication patterns.
But as we all know, peace never lasts forever. Section 4, investigating a production event. The dragon appears. Out of nowhere, one of your applications is suddenly experiencing a massive traffic surge and a catastrophic spike in errors.
Now, what's really interesting about this is the dramatic data contrast the AI suddenly has to process. In our baseline scenario, we had a very calm 10 requests per second and a 5% error rate. But in our simulated event,
It targets the Java Hotel application specifically. Bam! It's suddenly hit with 30 requests per second, triple the baseline, and a massive 25% error rate. The agent immediately detects this severe deviation from our peaceful status quo.
The very second it detects this deviation, the agent instantly initiates a 4-phase chronological investigation. First, data collection. It immediately pulls and correlates metrics from Amazon-managed Prometheus and error logs from CloudWatch. Second, the analysis phase. It applies statistical analysis and machine learning algorithms to compare this current chaotic behavior against our established baseline. Third, root cause identification. It maps out the exact event timeline with correlated evidence to find the real culprit. And fourth, the mitigation strategy, where it formulates actionable steps to actually fix the problem.
The sheer depth of analysis happening in the background during this crisis is truly remarkable. The agent performs cross-service impact correlation, checking if the failure in the Java Hotel app has a blast radius that's taking down other dependent services. It handles timeline reconstruction to show you exactly how this situation evolved, second by second. It leverages dependency mapping to visualize exactly who is at risk. And best of all, it provides prioritized remediation recommendations. It will pinpoint the exact failure mode, say it identifies a memory leak or a thread pool exhaustion, give it a confidence score, and then actually rank the fixes based on business impact, like recommending you scale the affected deployment or roll back a recent configuration change.
Section 5. Mitigation and Future Prevention, Restoring Peace. Okay, you can let your shoulders drop down a bit now. The immediate fire has been put out. The agent has provided the runbook-style guidance we needed, not just to fix the current terrifying issue, but to proactively prevent it from ever happening again.
And this is really the ultimate takeaway here. The AWS DevOps Agent topology automatically discovers and maps your entire infrastructure into an interactive, living blueprint. It doesn't just leave you with a fixed problem. It leaves you with a dynamic map that reveals exactly how your resources interconnect and drive your system's overall behavior. By analyzing patterns across all your incident investigations, it delivers targeted recommendations that continuously improve your operational posture and ensure ongoing stability.
So I'll leave you with this final thought. As cloud-native architectures grow increasingly complex, is your incident response ready for an AI upgrade? Having an autonomous agent that deeply understands your Kubernetes environment is very quickly moving from a nice-to-have luxury to an absolute necessity if you want to reduce operational overhead. Thank you so much for joining me for this explainer. I hope this dive into the AWS DevOps Agent has given you the clarity and the spark to modernize your own observability stack. Catch you next time.